All right, so continuing yesterday's lesson of quadratic formula and using it, there's a part of quadratic formula that you can use, and it's called the discriminant, and it's the expression that's under the radical sign. The radical sign is the square root sign. That's b squared minus 4ac. And what they've come up with is you can use the discriminant to figure out how many solutions a quadratic equation has, right? And it's just by figuring out what b squared minus 4ac equals. Right? If you were to have, like, this is just an example here of a quadratic equation. If you were to plug this into b squared minus 4ac, you get a negative answer. If you get a negative answer, it doesn't matter what that negative answer is, as long as you get a negative answer, you know that this is not going to have any x-intercepts. It has no solution. Like we learned on Tuesday when we were graphing, we were solving by graphing. If it never crossed the x-axis, then it was zero solutions because it had zero x-intercepts. It had no roots. It never crossed the x. If your discriminant, b squared minus 4ac, comes out to 0, which it does here, then it means it has one x-intercept, which means it has one solution. It crosses the x-axis one time. That means the vertex is on the x-axis. And if the discriminant comes out to be a positive number, again, it doesn't matter what the positive number is, as long as it comes out to be positive, you know it crosses the x-intercept twice. It has two solutions. So the reason I'm teaching you this is so if you ever have to know like how many solutions you need, right, you can tell that by just the discriminant, which is just what's under the radical sign, b squared minus 4ac. You can figure out and be like, oh, well, this was 0, so I know I'm going to only have one x-intercept. Okay. So they're going to give you this. So write this down. So the problems are going to say, what is the value of the discriminant of this quadratic equation? And then you determine the number of solutions. Right? So first thing is this isn't in standard form. This isn't actually quadratic equation, standard form of quadratic formula or equation because it's not equal to 0. You need equal to 0, so you have to add 3 to both sides to make it equal to 0. So now you have 4x squared plus 5x plus 3 equal to 0. Now you can figure out what the discriminant is. Now the discriminant, again, is just b squared minus 4ac, what was under the radical sign. So plug in your numbers. B is 5. So 5 squared minus 4 times 3. 5 squared is 25. 4 times 4 is 16. 16 times 3 is 48. 25 minus 48 gives you negative 23. That is part of your answer. That is the value of the discriminant. Based off that number, how many number of real solutions do I have?
0.
Okay, no real solutions. No real solutions. I wouldn't care if you went with the empty set symbol either. It's fine. Alright. So you have to have two answers. How many solutions? And you determine that by what is the value of the discriminant. So, any questions? Alright, so you need to write the quadratic equation here. 2x squared plus 11x plus 15. So it's already in standard form, so I just need to fill out b squared minus 4ac. B is 11, so 11 squared minus 4 times 2 times 15. 11 squared is 121 minus 4 times 15, which 4 times 15 is 60. 60 times 2 is 120. So 121 minus 120 is 1. 1 is positive. My value of my discriminant is positive. So that means I'm going to have 2 real solutions. If you just wrote 2 solutions, that'd be fine too. Alright, so check your answer to mine. We have b squared minus 4ac is our discriminant. So I'm going to go negative 30 squared minus 4 times 9 times 25. 30 squared. 30 times 30, or negative 30 times negative 30 is 900 minus, you got 4 times 9 times 25. Well, 4 times 9 is what? Oh, yeah. Well, I mean, 4 times 25. 100. 100 times 9 is 900. So, gives you 0. That's your value. How many solutions would you have? One. So, you write one real solution, what the book's going to say, or you just write one solution. We don't work with imaginary numbers right now, so you don't have to worry about them. All right, here's your homework for today.